Welcome. My name is Clint. I'm a Terraform and Nomad engineer, and I'm here to introduce Julia Ferraioli. All right. She is a developer advocate at the Google Cloud platform, and for the past few years has been focusing on developer productivity and related tooling. She is a recovering full-time software engineer and loves shiny new technology. So welcome, Julia.
Thank you. How's it going, everyone? This is the main stage. This is like a lot bigger than I thought it would be. I'm short enough though that I don't actually obscure the slides at all. So that was by design, just for all of you. So I was trying to figure out what to give them to introduce me, and I realized afterwards that the best thing that describes me is I'm a machine learning girl who took a wrong turn and wound up here, and it's an awesome place to be. So I've been focusing on developer experience, containers, orchestration, and all things that make the internet go. So today I'm going to take you through running a pretty simple application, take it from development all the way to running into production and adapting to changes with tools from Atlas and Google Cloud Platform. Okay, so let's get started. So the first rule of any good demo, and this is what I learned from the internet, is you have to show people what you're going to finish with. So we'll take a look at the demo, run through what technologies and tools are available to us in our toolbox, go through the process of making decisions about what to use, and then actually get things going. And then my favorite section, which is how on earth do you cope with success? Because that's almost as hard as coping with failure. So we'll look at what that would entail. So at the end of the talk, I'll give you the slides, the code, so don't feel like you feverishly have to take notes or take pictures of slides. It's all available online, actually, right now. Okay, so infrastructure demos can be pretty bland, especially if you have somebody like me responsible for designing them. I'm absolutely horrible at it. So luckily for all of you, I didn't design the UX for this. You can thank me later. Okay. So you may have seen this type of game before, and hopefully it shows up okay. So you are a spaceship in the middle of space, where you would ordinarily find a spaceship. And you see, let's call them space objects out in the middle of space. And you have to shoot at them, destroy them, break them up into smaller pieces, etc. So if you wasted a lot of time in the early 80s and 90s like I did, this probably looks somewhat familiar to you. So let's go to the actual application and take a look. So what I'm going to do is I'm going to bring it up on localhost, and we'll get into this a little bit later. If I can extend it, you can see me in the middle of space. I have a green spaceship, and I'm just using standard game controls to fly around. Now you can see that the stars are automatically populated. They just kind of show up depending where you are. But we don't actually see any of those space objects that I mentioned. And I'll get into why that might be later. So it's a pretty simple application. There's nothing super complicated here. You could probably take a look and go through the source code really rapidly. Okay, but this, called hyperspace, gives you hints that we might be extending the original concept to something a tiny bit more complicated. So it's called hyperspace. And if you could see on the right here, we've got some of those space objects that I mentioned. It's an open source application, and it's on GitHub as we speak, and we are just running it on localhost. It's written by a former colleague of mine and a present West Coast dev. Just to sanity check, Nat or Ken, are you in the audience? Okay, yay. That takes a lot of pressure off. So it's, again, not terribly complex. It's got a JavaScript front end and a Go back end to keep track of state, etc. But unlike its ancestral game, it's improved a little bit. Not only is it playable in the browser and not in an exe, it also is multiplayer. So in the upper right, you saw the one player online, and if you get other people to join, you can see generally where the other spaceships are located, and go to them, fly to them. Word of note is that you can actually harm each other in hyperspace. So if you shoot at each other, you can destroy the other ship. Also, you can completely crash, and then it's game over, and there's no more playing for you. But why didn't we see any of those space objects out when we took a look at the running instance? Well, that's actually because it has unlimited bounds. So it's much more like kind of actual space. It's not nicely confined in this tiny little screen. So the space objects tended to drift off the screen, and because this particular instance has been running for a while, who knows where they might have gone. But because it has unlimited bounds, it also has unlimited fun. So that's a note to you. You can have a lot of fun chasing space objects in this game. Okay, so let's take a look at how we might go about building up hyperspace from a development environment all the way to production. So the first thing we have to ask ourselves is, what's actually in my toolbox? What tools are available to me? And you all have a much better idea of what's in your toolbox than I do. So I'm going to talk about what's in mine. At Google, we've been consistently and steadily adding new and improved tools to Google's toolbox. And we call that our cloud platform. I'm going to make some of my colleagues cringe just a little bit here. I often joke that at some point we're going to need to make flashcards for all of our blue hexagons that represent all of our products. These are just a few of them. Or I should point actually to the screen there. Just a few of them. Some of them may look familiar. We've got anything from compute powers to make your applications go, storage so that you can store what you want, where you want, in whatever format you want. And we even have tools that allow you to query massive data sets fast and easily. But today, we're only going to concentrate on a few of them. At the center, we've got Compute Engine. This is our infrastructure as a service. And down below, we've got developer tools and cloud networking. And these go what we think is pretty hand in hand. So we'll go through, use these tools to make hyperspace go. However, our cloud platform tools work really well with any number of third-party tooling, and especially well with the HashiCorp tooling. So let's make it even better together by combining them. We'll start off using Vagrant to create our development environment and make sure that, that hyperspace runs well. We'll create images with Packer so that we can share and distribute them. Deploy it onto production infrastructure with Terraform, and Atlas is overseeing the whole thing. So let's get started. The creation stage would ordinarily be where you start creating your application. Makes sense. But in this case, we've got an open source one. It's already written for us. So we want to run it in our development environment to make sure we understand it, its dependencies, and to automate it all with pretty scripts so that there are no manual steps whatsoever. So this is where you would probably say, where do I start? Do I start on my local machine or with production-ready infrastructure? And I know what you're thinking. And this is a picture of my actual desktop environment, Beaker, Finger, Puppet, Sea Monster, Print, and all. And that's an actual picture of Google data centers. You've probably seen some of them. They've made their way into stock imagery for data centers. So I know what you're thinking. You're saying, well, the one on the left, that's got Scotch. Let's go with that. So I happen to agree with you. Let's go with that. Let's run Vagrant locally to create a virtual machine and make sure that hyperspace is pretty well defined there. OK. So I'll also take you through how to do this in a data center if you think my local setup looks just a little bit unreliable. You know, it happens. OK. So what we have here is probably the simplest of Vagrant files. And this looks really familiar to you, right? We're using a recent version of Ubuntu as the base operating system. And we're mapping port 9393 to 9393. And this is because when you're running hyperspace in development mode, that's the default port it runs on. We've got a few scripts to bootstrap and make sure that we're running hyperspace with all the dependencies, configuration that it requires. And I'll take you through those a little later in today's talk. But we've actually already done this. So we've got hyperspace running on localhost 9393. If I go to my terminal, actually, let me go to Sublime Text. Is that a good size for everyone? Is that pretty readable? OK, great. It's hard to prototype that on a tiny screen. So this is our actual Vagrant file. It's the exact same thing that I showed you in the slide. There's nothing super special here. I'll take you through like the back end. It just installs hyperspace, some Go dependencies, and starts it up. The front end installs Nginx and configures things. That's pretty much it. So if we go to our command line, and I have to actually get my cursor in there, and type Vagrant status, we'll go all paleontologist style here with Vagrant. And you can see that it's actually running already. And we can do Vagrant SSH to drop ourselves into it. Get it back at the top. See that we've got hyperspace and everything that entails. So this is probably very familiar to everyone here. OK. So hyperspace is running port 9393 on VirtualBox and accessible on our host machine. OK, so let's go on a brief tangent and take a look at what starting up an environment in a production-ready data center would actually look like. How do you use Vagrant with Google Cloud Platform? And that is going to take us on a tiny bit of a tangent. So this is you saying, no, your desktop environment looks a little bit unreliable to me. And I would say you are probably very right and quite astute. So we're going to say we're just going to interact with Vagrant on our local machine, and we're going to use it to start up our environment in a Google data center. OK, and what does that mean? Well, when we think about compute at Google, we typically think about it along a spectrum. And that spectrum goes from getting very close to virtualized hardware all the way to abstracted computing power. And that's, running your infrastructure and as close as you can get to a server in your closet. And I've actually had to administer a server in your closet. Summertime is not fun if you don't have air conditioning. So at the virtualized hardware stage, we have Compute Engine. And this is Google's infrastructure as a service. You start up a virtual machine. It starts in blazing fast time. And you manage it all, right? You can start up one VM. You can start up 1,000. And you can get it as flexible as you would like it. On the other end of the spectrum, we have App Engine. And you may have heard of App Engine. This is one of Google's oldest cloud products. And it's what's known as a platform as a service. It has runtimes in Go, in Python, in Java, and PHP. And you get a lot of great developer tools here. You get accelerated development time because you have a lot of APIs to accomplish common tasks. And you can scale easily, but you sacrifice some of the flexibility. And that's where the continuum comes into play, because we've got something in the center called Container Engine, which is basically manages a cluster of containers. But for our purposes, we're going to use Compute Engine. We've already got it running on a virtual machine, and that's really what's going to be the most suitable for us. So when we use Vagrant to start up an environment with Compute Engine, our Vagrant file is going to change slightly. It's going to look, first of all, we have to install the Vagrant plugin, the Google plugin. And it's a one-liner. It's Vagrant plugin install. It goes really rapidly and easily. And once you have that, then you can proceed to modifying your Vagrant file. It's going to look a little bit longer, I'll admit, but it's pretty logical. At the top, we have a section to tell Vagrant how to access Compute Engine. Now, the unit of development with Google developer products in general is called a project. And you can have many projects, but they each come with one project ID. And within that project, your virtual machines can talk to each other. It's really simple. We've simplified the networking between them so that it's intuitive. For this, we're going to enter our project ID, and the way that Vagrant interacts with Compute Engine is with what's known as a service account. And this service account acts on behalf of you with your project. So that's that section of it. And then we need to tell it what type of machine to start up. We're going to just start with one of our standard instances. It just has about 1 CPU and about 4 gigs of RAM, sticking with Ubuntu, and this is going to be in one of our US zones. Okay, so in the interest of time, wrong way, there we go. In the interest of time, I'm not going to actually start up the Vagrant environment with Compute Engine, because we'll see what it looks like to spin one up with Atlas. But at this point, you're just basically out in space, all alone, in a multiplayer game, and you start up multiple tabs, but you can load it, but it's really hard to play multiple games at once with one computer. And it's a little bit lonely. So that we don't drift endlessly in isolation here, we're going to move on. So let's embark on the steps to get hyperspace up and running in a place where a bunch of people can play. And the first thing that we need to do is build up images. And we're going to do that with Packer. Now, you can create images with Google Cloud Platform tools, but Packer makes it super simple and easy to do, and so that's what we'll go with. What we're going to do is create 2 images, one for the back end and one for the front end. That's a pretty logical separation, makes sense. Okay. We have 2 JSON files to specify both parts, and I've conflated them slightly in the interest of, well, screen space. They're very, very similar. So up here, we have, again, the project information and account file. This is a JSON file you download straight from the developer's console. And we'll tell it where we want it to actually create the images. Again, we're going to operate in the US zone. We're sticking, again, with Ubuntu as our base image. And then we'll install a bunch of software, depending if you're on the back end or front end. And I'll show you what that looks like. So the script files that we took a quick look at before are just these shell files. They install Go and Nginx, as you saw. The backend clones and builds hyperspace. And the front end makes sure that the Nginx config is appropriate for what we want to do. And then once we create the image, we want to make sure that when we use the image to create an instance, that it starts upon reboot and everything's good to go. And there's, again, no manual steps needed. OK. So at the end of our JSON files, we have, in the post processors, what kind of artifact we actually want to build. And here, we're going to create a Google image. So let's go ahead and use pretty typical Packer syntax to do it with hyperspace. So I'm going to switch back. We're going to go to Sublime Text and open up our, let's see, JSON files. Yay, great. OK, so again, up here, we have information about our builder. I just want to show you the expanded provisioner section. And this is for the back end. So you can see we have the script files that I mentioned. We also have a configuration file so that we can adapt really easily. The post processor is exactly what we said. We're adding some metadata in so that we can identify which image was created when. So let's switch to the terminal. OK. So what we have here is just our Packer directory. We have both JSON files and the scripts. So we'll just do Packer build, and let's pick the backend. So what this will do is go ahead, start up the compute engine instance, install the software specified by the JSON file, and create the image. And if we go back to the browser, I'm going to load up our developer console. And we can see here, this is where we go and interact with the nitty-gritty of what's happening in our cloud platform project. So I'm just going to reload it. You'd say, well, why doesn't it actually automatically fetch the resources? Well, we actually build this on top of the same APIs that you can use. So we don't want to waste any quota. We can see that the machine that Packer build started up for us is already ready to go. And it's already configuring itself. But if we do this, Atlas isn't really going to know about it. So instead, we'll go back to the console, and we'll do Packer push minus name, Julia Ferraioli, hyperspace backend, hyperspace backend.json. Let's see, that looks right. And now we can see the push was successful. So let's just go ahead and do that for the front end as well. And again, so you can see that you don't see any of the typical input that you would see if you run it locally here, because we can go to our dashboard and take a look at our builds here. And Atlas is taking care of it. So you can see that I've actually done this a few times. I do practice for these presentations. So let's take a look at our front end. And right now, you can see that it started the build. Let's take a look at this. We can actually go into the logs. And this is the same output that we saw running locally, except this is happening via Atlas, which is pretty cool. So let's go back to our builds, and I'll show you what happens on the first time. So the first time I initiated these builds, it errored out. Super embarrassing. And we can see exactly why. If we see the output here is it's complaining and chiding me that a project ID must be specified. And I'm like, oh yeah, that's probably correct. And what we had to do is go into the variables section and add our project ID here. And this is pretty cool. I really appreciate this about the interface here, is that you have to mouse over it to actually see the value. OK, so let's go back to all of our builds. We can see here that it's telling us that we've got about 2.5 minutes to finish. Let's take a look at how our local build is going. And it's actually finished. It finished a bit ago. So we've created a disk image, and we can see that in our console. So I'm going to scroll down in our compute engine section to images. OK, so what we have here, in addition to all of the operating systems available with compute engine, we've got a few of them. It doesn't take this long to scroll down when you've got a smaller screen. We have the back-end image that we created locally. OK, so that makes a lot of sense. We can look at it. We see what time it's created. We've automatically enabled encryption for it. So encrypted by default is kind of how we like to go. And it's available to use. But unfortunately, because we did it locally, Atlas doesn't know about it. So what we really want is these two builds to finish so that we can use it later. So we can take a look at hyperspace backend. And it's still running. And it's just it should finish running in just a few seconds. So let's take a look. So right now, it's creating the image. So what happens is we actually create the instance, install all the software, then shut it down and delete it, and use the disk to create the image. OK. So let's go back to the presentation. That will finish in a few minutes, or a few seconds, actually. But let's move on. OK. And get to the deploy section. So we've tested our application locally. We've built our images, or if they're not done, they will be very, very soon. And Atlas knows where they live. So once the Atlas builds finish, we'll get a link to the Google image that you can see there. And you can look at all the metadata associated with it. And so now it's time to actually go and deploy to production. And for that, Terraform is the logical choice here. So let's take a look at what that might look like. So our Terraform file is pretty typical. There's nothing super surprising here, right? We've got the provider that we intend to use. We're going to use Google. I do work there, after all, so why not? It's also ridiculously fast. We've got the same information as we did before with the account file and the project ID. We're sticking with the US Central Zone since we're here. And then we're going to go ahead and describe what kind of images we're going to use to run hyperspace. And here, we're using a Google image. So again, I've conflated the back end and front end slightly so you can see them in one slide. But there would be two of these. Moving farther on, we're actually going to describe the instances we want to use to be responsible and give them some information about what machine types. Now, I'm using the standard instance. I could use a high CPU instance or a high memory instance or up the cores. But hyperspace isn't all that taxing to run, so we're just going to stick with the one CPU. And then we're referencing back with the image here. This is the image that Atlas knows about that we've created. Finally, we take a look at how the networking is defined. So here, we're just using the default network, and I'll show you what that looks like. And we've got one thing I want to draw your attention to, and that's the count number. So for the back end, we're just deploying one instance, but we could up that or modify it as however we want. So to let Terraform know that we should go ahead and deploy to production, all we have to do is run Terraform apply. Now, what it's going to do is it's going to say, well, I'm going to take a look at what's already deployed. And right now, that's nothing, right? Once Packer finished the builds, it shut down the virtual machines, so they're no longer there. Our environment is pristine. And it's going to say, oh, okay, well, you need one backend and some front ends. And it's going to go start those up with the images we wanted and deploy to production so we can try it out. So let's go back and go to our main Terraform file. So again, our provider, our resources, you can see them separated out now, both using Google Images, and the instances here described. I want to scroll down to the front end to show you that we are, in fact, telling it that we want to use 2 front ends. And we're going to create a load balancer between them. So we're just going to create one load balancer, a forwarding rule, and we're going to output the IP address of the resulting load balancer once Terraform has applied all of the changes. So let's go ahead, switch to our Terraform tab, and do Terraform apply. So again, it's doing the diff, what's there, what's not, and reconciling the differences. And let's go and see what it's going to do. So let's go back to Compute Engine. Let's go to the VM instances. We might have to, oh, nope, it's already starting it. It's starting 1 backend, 2 front ends. They're still in the booting stage. They're going to be using the images that we created. So here's we've got 2 of the hyperspace backend because we did one locally, and 1 from Terraform, and we've got 1 front end. Going back to the instances here, let's take a look at the output for the command. It looks like it's going okay. So let's refresh, use up another precious quota there, and we can see that the instances are ready and available to use. So I want to show you just a bit about the networking. Here we have our default network. We've got some firewall rules in them that you can examine. And we've got that load balancer that we created. Here's the forwarding rule. And if we dig into that and look at our target pool, let's see. One second. Here we go. We can see that it has 2 instances in the pool. And it's chiding us that we don't have a health check because we're obviously very bad people. So, but if we go back to the terminal, it's output our load balancer. So IP 104.197.200.163. And I might be foolish, but if anyone wants to join me, you're more than welcome. Hey, there's 2 players. Cool. Oh, and so you can see the other player. You see the blue arrow at the top of the screen. Oh no, you're shooting at me? Really? Okay. And so somebody got me, or an asteroid got me. Oh, space object got me, so game over. It reloads it. It's a new life. Okay. So you saw that was 16. Awesome. Okay. Wow. This is too much for me. I'm going to get out of here. I'm actually very much a pacifist here, so it's a little scary for me. Okay, so that's Terraform apply. Now, obviously, we got 16 people on board. It's hyperspace is a huge success. You want to start advertising, et cetera. And how do you actually cope with your success? And here's where we are going to take a 1-line change And with Terraform apply, create more resources for us to use. So let's go back to our Terraform configuration file. This is our resource for the front end. We're going to up the count. Let's say 14. We're going to up it to 14 instances, handling incoming requests. Go and say Terraform, let's do just that. Terraform apply. It's going to go out. You've already got 2 instances. It's going to start up 12 more for us to use. And it's going to go ahead and create all of those, insert them into the load balancer so that we don't have to do hardly anything. You can see here they're starting up. If we refresh the page, they'll probably be good to go in just a second. That said, because they're not started, we can still use the existing ones. We've got our second front end was already there, as was our first. And we can go and take a look, here. And it says, hey, we've completed creating all of these front ends for us to use. And it's easy, straightforward, and it's exactly the same command that you would use to actually deploy it in the first place. OK. And it's not, right. And it's still there. It's still running. And it doesn't matter that we're adding things to the pool. Oh, OK. I'm out of here. OK. So that is pretty much how to go end to end with tools from HashiCorp combined with our cloud platform tools at Google. We're really, really proud of Compute Engine. Just a couple of things. It's really fast to start an instance. It goes by very rapidly. There have been times where I do a Terraform apply, wait like a couple seconds to get back to my browser window, and already the instances have been created by the time I refresh the page. I'm constantly impressed. So at all points in the cycle, there's a story to take you from your tools with HashiCorp into running at Google scale with Google Cloud Platform. You can easily use Vagrant to create reliable environments on Compute Engine, Packer to build up the images that can be used to spin up instances very rapidly. And then we then can use Terraform to deploy our cluster. I'll admit we ran out of time for console in today's talk, but we can easily see how it would fit into the demo, managing configuration between the back end or backends and front ends. It's a pretty symbiotic relationship, and I hope you'll try it out. So, as promised, I'm not leaving you hanging without a few pointers. For all of our cloud-related documentation, it's just hanging off of cloud.google.com/docs. The code from the presentation, hyperspace, and hyperspace is out there. The code to get it up and running using HashiCorp tools is out for a pull request right now, and that's waiting on us. So all of y'all at HashiCorp are doing a great job there. The slides are on speaker deck, and I see it actually cut off the URL. So at the end of workflow, there's a -1 additionally. Hyperspace and Vagrant and GCE, both on GitHub today, and great tutorials. OK. Oh, shoot, I always forget about this one. There's a free trial for Compute Engine. It's something like $300 over the course of 3 months to go out and play. And I think it's all of the cloud products, so anything from Compute Engine to BigQuery, it's all right there. So take a look. So before I wrap up, I want to just do a major shout out to Eric Johnson, who's been working tirelessly with the HashiCorp folks to make sure that there's a really graceful story between them and Cloud Platform. And thanks to HashiCorp for putting together an awesome conference and having me come and talk. So in the time we have left, I would like to take questions if anybody has some. And I can't really see you all because there's a lot of light. So, questions, anyone? Okay, I think, oh, there we go. Hey, how's it going?
Good. So I saw that Atlas helped you with the build process.
Mm-hmm.
And where else have you used Atlas? How has it helped you together?
So the question is, how else have we used Atlas to do this whole example? And so the idea is that if we keep going with the hyperspace application, there would be more points of integration, like taking a look at the topology of what we've deployed, et cetera, getting further integrated with logs and monitoring. That would be the next step. And of course, like I mentioned, console would be great to help us get it all tied together. And that is how it would further integrate with Atlas. Anyone else? If I squint, I can see you. Okay. Well, I'll be around for the next couple of days. So, and there are a few other folks from Google. So thank you so much for joining. See ya.